One.
Hello, everyone. I'm happy to be here at the distance. I would love to see you face to face, but maybe next time we will do that. So I'm Magda Miu, and today we will talk about how to achieve high performance by using idiomatic Kotlin. So multiple factors usually shape the experience of our users. And based on the studies, users have a more positive feeling about fast loading pages. A fast website or an app for sure give us a sense of progress. The users feel they are moving quickly towards their goal, and that increases satisfaction. Also, the studies show that 40% of the people abandon a website that takes more than 3 seconds to load. Worst, 79% of users who are dissatisfied with the website's performance are less likely to buy from the same site again. However, poor performance and reduced satisfaction will not only damage the customer satisfaction, they hurt also the brand of the company. And this is happening because 44% of users will tell their friends about a bad experience online. So what is the lesson we should learn from this slide? Is that poor performance reduces the user satisfaction, can drive users away, and for sure damages your brand. So in this talk, I will emphasize the role of the performance, how we can measure it, what are the main reasons that can contribute to lower performance, and finally we will talk how to use Kotlin in order to solve all these challenges. Like you already know, Kotlin's philosophy is to create a pragmatic language for the industry, not an academic one. So I will focus on showing you why developers love this language and how it could help us to build products by writing maintainable and secure and expressive Kotlin code in an idiomatic way. When we talk about performance, we talk about multiple things. We could talk about the response time, how fast the data is transmitted, about the availability, or how we use the device's resources. But first of all, we should remember that we build products for customers, so we should concentrate on factors that affect their experience. We don't want to have poor performance. So it will be better to identify the bottlenecks when they begin before they begin to have a negative impact on the user experience. Usually the time changes with the situation. So have you ever been in a queue waiting to buy or pay something? Do you remember how did it feel? How was the time passing? Was fast or slow? Usually you feel it's take very slow. Is the difference the clock measures, and subjective time is what we all perceive. So actually, when users report that our app is slow, we usually focus on making it objectively faster. So we work to reduce the load time by a certain percentage, or also we try to improve the user experience. Objective time is easy to measure, so this is why we focus on it. There is also this concept of just noticeable difference that says that any human observable phenomena needs to have a certain level of difference in order for that difference to be noticeable. For example, if you show to someone 2 light bulbs and ask which is brighter, a bulb should be some level of brightness above the other one in order to make that difference noticeable. So even if our app is statistically performing well, the real measurement should focus also on how the user perceives that performance. And Steve Steyer from Microsoft found that the G&D threshold for time is 20%, about 20%. So if our app is slow and you focus on improving the objective speed, it should be 20% faster than before in order to make that difference noticeable. Our activities usually tend to be divided into different phases, active and passive phases. The active phase is characterized by a high level of mental activity. We are engaged with that app, we finish some tasks, we move on, and so on. When the passive phase is characterized by waiting something to happen. And all these feelings and all these phases are actually determined by the dopamine. And based on Richard Larson from MIT, humans overestimate passive waits by 36%. So what we should do is to make passive phase less painful and make active phase a greater proportion of the total time. Okay, now we are going to uncover the main reasons for performance issues that relate to the apps based on JVM. So on the apps, in our case, developed using Kotlin. We'll talk about reasons for performance issues like memory management, heap fragmentation, resource and memory leaks. And also we'll cover a little bit the slow rendering because we are Android developers. But first of all, let's do a short recap about how the JVM architecture is structured. We have three different layers. We have the close loader responsible to load the classes in three different phases. We have the load phase, the link phase, and the initialize phase. After that, we have the runtime data areas where the things are stored actually. And here we have area or meta where we have anything related to the objects. We have the Java stacks where we have the stack frames corresponding to the current method for each thread. And the program counter registers that contains the pointers to the next instructions to be executed per thread. And usually they could contain also pointers to the native method stacks area. We continue with the execution engine that includes the interpreter, which is responsible to understand the bytecode and to execute it. We have the JIT compiler that it's the one that actually responsible to compile the code, the bytecode, and get the target machine. And together, the target machine code, and together with the hotspot profiler, it's able to optimize this process. So the hotspot profiler actually keeps an eye on the bytecode that is run and helps the JIT compiler with the frequent use bytecode to be somehow cached and be very easy to be retrieved and used. And finally, we have the garbage collector that is responsible to clean up the memory. Because the JDK introduces that bridge between the bytecode running on JVM and the native code that usually is written in C, C++, we have this tool, which is called Java Native Interface, which is a different layer that also interacts with the execution engine and with the metadata areas. Now, let's focus on the memory management. So the garbage collector is responsible to get objects, find objects that are not reachable and reference and destroys them. And this mechanism is based on a set of objects, of root objects actually, that are always reachable. And an object is a root if we have local variables or active threads or static variables, and sometimes also Java native interfaces references. Now, how the garbage collector could impact the performance? The idea is that this could also depend on the implementation that it's using behind the scenes, also on the number of objects or the size of the heap. And actually, the garbage collector needs time to detect the reachable and non-reachable objects. And when the integrity of the reference tree is difficult to be achieved, the stop the world is happening, that the garbage collector pause event. So the execution of all threads is suspended. And for sure, this action will impact the performance and the experience of our users. When we talk about the heap fragmentation, we actually talk about also two different challenges. The first one is referred to the fact that when we use the app and we need to allocate some space for our new created objects, at the moment in time, it's becoming too difficult to find the next free block of sufficient size for our objects. This is one of the challenges. And the second one is related to the fact that the unused space between the blocks of memory allocated starts to become so big that the JVM will be sometimes maybe impossible or pretty difficult to be able to create a new object in that free space. Now, the solution here is to use that mechanism that is called compacting. And compacting actually what it does, it moves all the reachable object, I mean all the allocated memory at one of the heads of the queue of the memory and allocate there the memory in a linear way. And the other part of the heap, it's free to be used. Now, when this mechanism of compacting is happening, the impact is that during this process, the app is suspended because it takes some time. And again, the performance and the experience of the user is affected. Now, when we talk about the resource and memory leaks, we are talking about, when we talk about the resources, we refer to, for example, files. This is the most common used sample. When we use a file, we open it and we forgot to close it. That is a resource leak. And in Kotlin, for example, in order to solve this challenge, we have the use extension function, which works similar to try with resources from Java. And actually behind the scenes contains the try with finally, and in the finally close that resource. This use extension function is applicable for the object that implements closable, just like try with resources in Java. Now, when we talk about the memory leaks, we are talking about the situation when the garbage collector is not able to release the memory. And in JVM, this thing can happen when a reference to an object that's no longer needed is still stored in another object. And here the solution, especially when we could have this kind of memory leaks in a multi-thread environment, the solution is to make sure we use as much as possible immutable objects, because when you use immutable objects, you are not able to change the state. And this is very helpful in a multi-thread environment in order to reduce the risk of having memory leaks or other bugs. Now let's talk a little bit about the slow rendering. Slow rendering could for sure impact the performance of an application and the experience of the users. And as Android developers, we all know that. And for sure, our users expect interactive and smooth user interfaces. They want the response type to be instant, and also the animation should be smooth. And here is where the development team needs to focus their efforts. And in order to create an application with an excellent experience, a developer needs to understand how to write a code that it's capable to run as efficiently as possible. Now, the device refresh rate, it's a hardware characteristic and is measured in hertz. And also based on the studies, the human brain receives and processes visual information in a continuously way. So this thing can be used to create the illusion of motion when images follow each other very fast. And based on the research and also on the feedback received from the user, 60 or more frames per second is what most people see as a high quality and smooth motion. And to be sure that user interacts with an application smoothly, the application should render one frame each 16 milliseconds in order to display those 60 frames per second. And we know that as developers, we should also take in account that the system needs some time in order to do its things. So it should be better to count on less than 10 milliseconds to do our work. And we know that when an application fails to meet this budget, the frame rate drops and the content is not so clear. Now, so far we have an understanding of what performance is. And now I think we are ready to see how we could measure these performance issues. And Peter Drucker, it's known for his famous quote, you can't manage what you can't measure. So measurement is a significant part of every management and technical activity. And it's important because measurement gives us the numbers, the objective information. And when we want to make decisions, we should be informed and not make those decisions just because we think it is like this or another way. We should make the decision based on numbers. How to measure the performance issues? There are two different possible ways by using the benchmarking and general performance metrics when we run, for example, some performance tests. Now, when we talk about benchmarking, we're actually talking about running the actual implementation on a real system. And we have here three options. We have the micro benchmarks. These are the metrics showing the performance of certain functions. And in order to do these measurements, a very well-known tool in the industry is the Java Micro Benchmark Harness. It's an open source project. There is also a plugin that could be easily integrated. And other than that, JetBrains prepared a repo that contains benchmarks samples for Java and for Kotlin comparison between the same elements. Another way is to use a challenge that could happen when you use the JM hash is that we can rely on it when some optimizations of the code happen when we run the same code again and again, because the compiler knows how to optimize those stuff. And in a real application, this optimization may be not applied. So we should be careful when we use it and take into consideration this aspect. Macro benchmarks, these are actually when applied when we want to test the entire application. And meso benchmark, it's a combination between the first two. So it could measure features or workflows. When we talk about benchmarking the performance of an app, actually we are checking it, the speed, the scalability, and for sure the stability of that app. And to do that, we could use also the performance testing. And for doing that, you should have in place a performance testing plan to decide on which kind of environment you will test, what kind of data you will use in order to perform those tests. And here are multiple options that you could use, multiple testing types. You have the load one, when you try to see how the apps works under an anticipated user load. The volume testing, when you have a lot of data that should be stored in the database and you need to see how the app reacts in those situations. The scalability testing, now you know that the Black Friday is coming and you will need to see how will react the app if a large number of users will use it. And stress testing, which involves testing the app under some extreme workloads. And the tools that could be used in order to analyze the results of the performance testing are multiple, and depending on what you want to achieve and the stack that you are using could be different choices. Gmeter is very well known in the Java world, and it's a very easy to use tool. It's also open source. For mobile, also it's recommended to use Firebase. They have that app performance part that could be very helpful. Also the Crashlytics part where you get the crashes. Another very good tool is Dynatrace. And this one is very helpful because it tracks the flow of the request from when the user clicks on the screen, touches the screen, until that request reaches the database on the backend side. So it follows the entire flow, and you are able to understand a lot of things about what's happening and where the things could be improved. And also for the backend side, you could use Grafana and Prometheus in order to have a better understanding of how the application reacted under those circumstances during the performance testing. Now, when we talk about profiling, we have here also a set of tools that could be used. We have the JVM Debugger Memory View, which is a plugin for Android Studio. If you I don't know, maybe run some Kotlin code in IntelliJ, you could use the memory view that's default view in the tool. JProfiler, again, it's a very well-known tool in the Java world, and it's also very useful when you try to profile Kotlin code. And flame graphs are a trendy tool used by Netflix. They also have a blog post about it. The only challenge they have is that they are not able to do such a great job when they try to profile the coroutines. Now, let's see, after we understood what are the bottlenecks, how we could measure the stuff, let's see how we could use the Kotlin language in an idiomatic way in order to boost the performance of our applications. We know that there are multiple programming paradigms. Kotlin is here. It's a functional and object-oriented language. And we know that the key concepts of functional programming are first-class functions, immutability, and not side effects. And also, Kotlin has a rich set of features to support the functional programming by default. And these include the function types, which allow us to use functions that receive other functions as parameters or return other functions. We have the lambda expressions that give us the opportunity to pass the code with minimum boilerplate. We have the data classes that help us with the immutability. And we also have a rich set of APIs for working with the collections in a functional style. Okay, now let's check a little bit the difference between the declarative and imperative style. This is a very easy sample. We have a list of numbers and we want to get only the even ones. So like we see here, a declarative style allows us to concentrate on what to do instead of how to do it. And the following examples from my slides will show you for each Kotlin piece of code what's happening behind the scenes. So actually we will see the decompiled Java code to understand better when we choose to implement the things in a way, what happens actually behind the scenes. We will start with functions. We have here's an example with a pure function. So we know that a pure function doesn't have any side effects like input or output operations and doesn't depend on a variable that doesn't belong to the scope of that function. And they are very useful in our code because they are easy to test, they are easy to refactor and reorganize. And using the pure function, it's an extremely powerful and reliable approach for developing applications that invoke parallel processing across multiple CPUs. So because a pure function returns the same value for the same input, for the same parameters, the compiler can optimize and just replace the invocation of the function with the results. So we get some performance improvements by using them. High order functions. We know that in Kotlin, the functions are first-class citizens. Which means that we can declare a function without being needed to have a class. And in functional programming, the trend is to reuse the behavior, to reuse the functions that already exist. And this trend has led to the creation of high order functions. And in terms of functional programming, a high order function it's a higher order function could be characterized by the fact that it takes one or more functions as an argument, or it returns a function, or it does both of them at the same time. And if we check this example, we see that we have this book class, this book object. We applied some filters, some functions in order to filter the information based on the author or the title of the book. We, after that, have a list of books and we apply those functions. Now, the challenge with this piece of code that it's between the pink rectangle is that this code is not so readable. It's pretty difficult to process the information and it's increased the cognitive effort. And other than that, can lead also to performance issues if you call again and again this piece of code, because each filter function is a loop under the hood. And to deal with this problem, we could approach different solutions. The first one could be to use a dedicated predicate, like the first option, or to use an anonymous function. And the third possibility is to use function composition. And this function composition, just like the name says, is the ability to combine two or multiple classes in order to reuse the code. And this is the main helpful thing by using them, because you are able to reuse the functions that already exist. Now, passing and storing pieces of behavior in our code, it's usually a frequent task. And functional programming offers us the possibility to do that. Actually, the possibility to treat the functions as values. And using lambdas, we can pass a block of code directly as a function parameter. Now, a closure, it's a function that has access to the variables that are defined in the outer scope of that function, of that lambda. It's also known as a capturing lambda because it captures a variable from outside its scope. In Java, if we try to run this code, we will get some compilation errors, because in Java, we are able to capture only the final, or effectively final, variables. So the difference between Kotlin and Java is that in Kotlin, we are not restricted to capture only the final variables. We can also modify variables from within a lambda. Like we have here, we have a var and a val, and we could access both of them inside of the lambda. And external variables accessed from a lambda are said to be captured by that lambda. Now here, we could also should be careful with the it convention. Yeah, it's great because we could write the code in a shorter way, but it could bring some complexity when we have nested lambdas. When we have nested lambdas, it could be difficult for the person that will read the code to understand better the context. So the recommendation here is to use names that specify the context. I don't know, if you have nested lambdas for some books, you should, and after that you make a narrow filter, you should specify what you got from the previous operation in order to help the person that reads the code to understand better the context. Now, how the lambdas are working behind the scenes. Under the hood, a lambda is actually an object that has the function of air type. And a lambda can take a varying number of parameters, of arguments, and behind the scenes, there are actually this functions file contains 22 interfaces that extend the function air interface. So we have a lot of options, but for sure we should be also respect the clean code principles when we decide how many arguments to use. We know that the Java allows only to capture only the final variables. And when we want to capture a mutable variable, we could have two different options. The first option could be to declare an array of one element in which to store the mutable value. And the other one, reflected here in the slide, could be to create an instance of a wrapper class that stores the reference that can be changed. The good part in Kotlin is that in the real code, we don't need to do this kind of trick to have this wrapper. We can mutate the variable directly. So this is an example with when we capture a mutable variable. And just like in Java, when we capture a final variable, a val, its value is copied. And when we talk about mutable variables in Kotlin, when we capture a mutable variable, a var, its value is stored as an instance of a ref class. And this ref variable is final and can be easily captured. Because here we have this example with the mutable counter. We see on the right side that we got an instance of the intref class, which in turn is referenced by the final intref counter. The Kotlin JVM internal package from the Kotlin standard libraries contains this ref class with implementations that holds values of all the primitive types and objects. So we are able to capture any kind of object we need. Also, for capturing expressions, a new function instance will be created every time a lambda is passed as an argument. And for non-capturing expressions, when we use, for example, pure functions, a singleton function instance will be created and used during the next calls. And here we have zoom in on the ref class, and we can see that that's why a new instance of function is created all the time. Actually, when you use capturing lambdas, this thing is not a cheap feature in Kotlin, and we should be careful when we try to use it. Inline functions. Inline functions are responsible to remove the overhead of the lambdas. And the magic of this function is that when we use that inline modifier, actually the body of the function is inserted in the bytecode where that function is called. So we don't have an invocation of that function. The entire body of the function is inserted in the bytecode. Now, for sure, actually the advantage of using this mechanism is that it allows us to reduce the runtime overhead of functions that take lambdas as parameters. So actually we avoid creating an instance of a function, so we save some memory allocation. Now, there are some situations where we should not use the inline modifier. For example, when we try to use the inline modifier for a function that doesn't accept another function as a parameter, we won't get any significant performance benefits. So it's not the case to use it. Also, the compiler will let you know that it's not the case to use it. And another warning when we talk about the inline modifier is that if you try to inline a function that contains multiple lines of code and is too big, it is not recommended to inline it, especially if you call it very often, because this will increase the size of the bytecode. So the recommendation is to split it with small functions. And you could also check, if you check the Kotlin standard library functions, you'll see that the inlined ones are very small. Okay, so if we take a closer look at what happens behind the scenes, we have this inline function operation. And this example shows that the compiler doesn't create an instance of the function type. Instead, it generates code that performs the body directly in the lambda. So we just insert that code there, and no extra overhead is created. We also have the possibility to use the no inline modifier. And here the compiler creates an instance of the function type, like as you can see, I hope you can see a little bit in the right. There was a lot of code generated there. So the idea is that there are some situations when you don't want to inline all the parameters of an inline function. And in order to achieve that, you have this no inline modifier. If you use the return keyword in a lambda, it returns from the function you call that to lambda, not just from the lambda itself. And such type of return is called non-local return, because actually it returns from a larger block of the code, not from the place where the return was called. And to indicate that thing to the lambda parameter of an inline function, we could mark that lambda parameter with the cross inline modifier. And this could be very helpful, especially when such lambda is passed on other execution context, such a high order function that is not inline, or we have a local object or a nested function. Reified types are very helpful when we need to access a type passed as a parameter. And here we could see that, sorry for that. Actually, what happens is that by using, we know that by using the inline modifier, the bytecode is inserted, the code of that function is inserted directly in the bytecode. And also by combining it with the reified type, the compiler will add in the bytecode the specific type of that variable. So when the type erasure mechanism appears at runtime, this will not affect the bytecode because we have a specific type, not a generic one. So it will not be removed at runtime. And here, if we check this code, we have a repeat from the standard library and another one made custom. And we actually have a performance difference here because the one done by us custom has a lot of overhead there. We check for nulls. We have a custom. We have an explicit custom number. And the repeat from the standard library is actually an inline function and reduce a lot the performance, the time of execution, so it improves performance. And a short summary about collections. It's recommended to use the read-only collections over mutable ones. It's also recommended when we have a big number of elements to use sequences. And when we talk about sequences, we have intermediate operations and terminal operations. The intermediate one are lazy, the terminal one are eager. And I really love this animation. It's made by Florina Muntenescu, and it shows exactly what is the difference between sequences and collections. And about the fact that the lazy evaluation for sequences process elements one by one, and for the eager evaluation, they are processed. We create a new collection at each step. And behind the scenes, for collections, the filter and map functions are in line. For sequences, is not. So this is why we should be careful when we want to use one and the other one. So prefer sequences only when we have a big number of elements. We covered a little bit the mutability. We mentioned at the beginning that we have it by default by using the data classes. Another example is disposable pattern. So this is actually what I described when I talked about the use extension function. We have this pattern applied there in order to avoid resources leaks. And also when we work with strings, we should use string templates because behind the scenes, it uses string builder. And also starting from the latest version of Kotlin, it involves dynamic invocation. So actually this helps a lot the performance because it defines some custom linkage on the behavior. The JVM field is very helpful to avoid creating the overhead of invoking getters and setters. And object lifting, it's very helpful. For example, here, in the first example, we call that mean each time. In the second one, we lifted the object to improve the performance. So my recommendation is to be curious and start with why all the time. When you have a feature to implement, analyze what are the options, which one is better, what's happening behind the scenes, and compare them and make sure you make the right decision in order to improve the performance and have a great experience for your customers. That's it from my side. Thank you very much. I will publish the slides on Twitter after this talk, and I hope you enjoyed and it was helpful for you. If there are any questions.